Spectrum. Dispersion of white light through a prism and formation of a spectrum. Dispersion. The phenomenon of splitting of white light by a prism into its constituent colors is known as dispersion. Spectrum. On passing white light through a prism, the band of colors seen on a screen is called spectrum. Electromagnetic spectrum. The spectrum of light which lies between the red and violet regions is known as the visible spectrum and is only a very small part of the entire electromagnetic spectrum. The part of spectrum beyond the red extreme and the violet extreme is called invisible spectrum. The complete electromagnetic spectrum is increasing order of their wavelengths or decreasing order of their frequencies is given below. Gamma rays, X-rays, ultraviolet rays, visible light, infrared radiation, microwaves and radio waves. Properties and uses of different radiations of electromagnetic spectrum. Gamma rays, wavelength below 0.01 nanometer. Source in cosmic rays from radioactive substances. Method of detection by their large penetrating power. Uses used in medical science to kill cancer cells, that is radiotherapy. To check welding. X-rays, wavelength 0.01 to 10 nanometer. Source from a heavy metal target of high melting point when highly energetic electrons are stopped by it. Method of detection. By the fluorescence produced on a zinc sulfide screen, the photographic plate gets affected. Uses. Detection of fractures in bones, teeth, etc., that is radiography. Diagnostic purposes such as CAT scan in medical science. Studying atomic arrangement in crystals and complex molecules. To detect concealed precious metals. Ultraviolet rays. Wavelength 10 to 400 nanometer. Source sunlight, arc lamp, spark. Method of detection. By their chemical activity on dyes, photographic plate gets affected. It causes fluorescence. Uses for sterilizing air, surgical equipments, etc. For detecting the purity of gems, eggs, ghee, etc. In producing vitamin D in food of plants and animals. Visible light, wavelength 400 to 800 nanometer. Source sunlight, light from electric bulb, flame, white hot bodies. Method of detection. Other objects can be seen in its presence. Uses used in photography, photosynthesis to see the objects around us. Infrared radiations, wavelength 800 to 10 to the power 6 nanometers. Source lamp with thoriated filament. Heated silicon carbide rod, red hot bodies. Method of detection. Heating effect is more. The mercury rises rapidly when a thermometer with a blackened bulb is kept in these radiations. Uses used for therapeutic purposes by doctors. Used in photography at night. Infrared lamps are used in dark rooms for developing photographs, in remote control of televisions and other gadgets. Microwaves, wavelength 10 to the power 6 to 10 to the power 10 nanometer. Source electronic devices such as crystal oscillators. Method of detection oscillatory electrical circuit. Uses used for satellite communication, for analysis of atomic and molecular structure, for cooking in microwave ovens and in radar communication. Radio waves, wavelength above 10 to the power 6 nanometer. Source TV and radio transmitters. Method of detection aerials of radio and TV receiver. Uses mainly used in radar communication, radio and television transmission. Scattering of light. Scattering is the process of absorption and then re-emission of light energy by the dust particles and air molecules present in the atmosphere. Some applications of scattering. Red color of the sun at sunrise and sunset. At the time of sunrise and sunset, light from the sun has to travel the longest distance of atmosphere to reach the observer. Since blue light of short wavelength is scattered more, much of it is lost, while red light of long wavelength is scattered a little, so it is not much lost. Thus blue light is almost absent in sunlight, reaching the observer, and only red light reaches us. As a result, the sun and the region nearby it is seen red.